Hello and welcome once again to Mathspirational. In this video I'm going to be going through the answers to the ASU Mathematics Initial Assessment at King Edward VI College for September, August 2015. Okay, so without any further ado, let's crack into question one. Nice easy start to the test. We just need to rearrange stick the brackets into our equations to make them work. So part A. Wow, it's going to edit this thing out, isn't it? And we've got to start with 6 plus 2 times by 4 equals 32. So if we just use our ordinary order operations, we'll do our 2 times 4 first, which is 8, plus 6 is going to be 14. Well, that's clearly not 32, so that's currently incorrect. Now, we know normally in our order operations we do multiplication first. However, putting in brackets around the addition would mean that we would do that first, followed by the multiplication. So let's stick those brackets in and see what happens. So, now what do we do first? First, we're going to be doing our 6 plus 2 is 12, times by 6 plus 2 is 8, times by 4 is 32. Hello! That works. Excellent. Okay. Part B. So to start off with, we've got 6 plus 2 times by 4, take away 1 equals 12. So again, let's have a quick look at this. If we were to do without any brackets in it at all, we'll do our 2 times 4 first, which is 8. We would then add our 6, so that gives us our 14 again. And then we subtract 1 to get 13, which isn't 12. Okay, so that's not working. So we're either going to have to put brackets around our 6 plus 2, or our 4 minus 1 to make this work. So let's have a look at that. Well, if I put my brackets around the 6 and the 2, I'm going to get 8. So I'm going to get 8 times 4 is 32. Take away 1. Well, that's clearly not going to work. So let's have a look. If I put my brackets in around 4 minus 1, I'm going to get 3. So that's going to give me my 2 times 3 is 6, plus the 6, oh happy days. That works. Okie dokie. So, part C, we've got 6 plus 2 times by 4 squared equals 70. So I need some big numbers here. So just sticking the brackets around the 6 plus 2 is going to give me 8. 4 squared is 16. 16 times 8 is not 70. So that doesn't work for me. What does work? Well, let's have a look. See, if I stick my brackets in there, though, I'll get my 2 times 4 is 8. 8 squared is 64. Plus the 6 is 70. Happy days. Okay, so that's our first 3 marks in our first question. Moving on. Question 2. It's a relatively straightforward equations to solve in part A. So we'll start by looking at A part 1. And we've got 3x plus 7 equals 15 minus 2x. So we need to rearrange it so that all our x's appear on one side and our constants appear on the other side. So give us a nice straightforward equation. I'm going to start off by getting rid of my negative 2x from the right hand side. I don't want this here. So I'm going to add 2x to both sides. So it's going to give me 5x plus 7 equals 15. So I'm putting my x's onto the left hand side. So I want to get to my constants from the left hand side. So I need to get rid of my plus 7. So to get rid of my plus 7, I'm going to subtract 7 from both sides. So we get 5x equals 15 take away 7 is 8. So now we've got 5 lots of x is 8. So that means x is going to be 8 over 5, which is 1.6 if we want that as a decimal. Okay, so straightforward. GCSE grade what? DE question. Okay, so part 2. Slightly more interesting. We've got 8 over x equals 2. This tends to trip up some people. So we've got an x in our denominator. We don't want it in our denominator. So how can we get rid of divide by x? we can multiply both sides by x. So if I do 8 over x times by x, suppose x is going to cancel out, leaving me with x. If I multiply my left hand side by x, I need to multiply my right hand side by x. So I get 2x. So I get, let's move that down a little bit. I get 8 equals 2x. So I'm going to divide both sides by 2. So x equals 4. Happy days. Okay. So part 3, finally, I've got 3x squared equals 75. Okay, so again, I want to have just a plain old x on my left-hand side, and all my coefficients and constants got rid of onto the right-hand side. So, get my x squared on its lonesome. Firstly, I'm going to divide by 3. So, I'm going to have x squared, since 3 divided by 3 is 1, is equal to 75 divided by 3 is 25. Okay, so x squared is 25. So then I need to square root both sides. So if I do that, square root and the square are going to cancel out, leaving me with just x. But on the right hand side, I want square root of 25. However, I've just made a boo-boo. Hopefully, some of you instantly recognise that what that boo-boo was. I forgot something. It's got a plus and a minus there. The reason for that is, well, firstly, square root of 25. Hopefully you recognise it's 5. While 5 squared is 25, minus 5 squared is also 25. And quite often at GCSE, when you solve equations like this, you got away without working out the second solution. Now moving to level 3 courses, you've got to remember to always include that plus or minus there. Really very important. Sometimes you'll neglect it and ignore it, but you have to work out the plus or minus first and then say, I am neglecting this solution. So in here, we've got no reason to neglect the negative solution, so we include it. Okay, moving on. We've got some brackety stuff. We've got some expanding, some factorizing. So firstly, expand. I've got 4x lots of 2x minus 7. So if I've got 4x lots of 2x minus 7, I'm going to want 4x lots of 2x. So that's going to give me 8x squared. 2 times 4 is 8. X times x is x squared. And I'm going to get 4 times 7 is 28. So minus 28x. Okay. Next up, factorize. So we've got 6 plus 8x. Okay, there's no quadratics, so we're just looking for a common factor. If we look at 6 and x, sorry, if we look at 6 and 8, the common factor is going to be 2. So your number goes into both of those, other than 1. There's no x in the first term, so I don't share any factors involving the x. So if I take a factor of 2 out of 6, I'm left with 3. Take a factor of 2 out of 8x, I'm left with 4x. There we go. 2 lots of 3 plus 4x gives me that in fully factorized form. Okay, part D. Nice little bit of rearranging. So, we are asked to make x a subject. So I need to move all my x's onto the left-hand side, and then all my other terms onto the right-hand side first. And then I can worry about there being more than one x. Okay, it's a linear equation. So I can do that. I don't need to worry about having to factorize straight away because I haven't got a quadratic. So I've got x plus 3 equals 2a plus bx. So like I said, I want to move all my x's, in this case, into the left-hand side. I could go to the right-hand side, but if I do that, I'm going to have some negatives where I don't really want them. So I have bx onto the left, so I have to subtract bx from both sides. So x minus bx. Plus 3 equals 2a. I don't want that plus 3 on the left-hand side, so let's get rid of that by subtracting it from both sides. So we get x minus bx is going to be 2a minus 3. Okay, so left-hand side, I've got 2 terms, both of them with an x in. So I can take a factor of x out that left-hand side. like that. So to get x all on its lonesome, all I have to do is divide through by my 1 minus b. So I get x equals 2a minus 3 over 1 minus b. If you left the brackets in the denominator, that's fine, but just redundant. Don't have to worry about it. Okay, that's question 2 done. Moving swiftly on to question 3. We've got ourselves a lovely histogram. So let's make it a little bit smaller so we can actually see what's going on. All on one screen. So, some light bulbs were tested to see how long they lasted. This histogram summarizes the results of a sample of 100 light bulbs of one type. So we've got a histogram, so straight away we should be thinking that frequency is area. Excellent. So, does this company make any claims? Well, of course it does. It'd be a rubbish exam question if it didn't. So, what have we got? We've got it claiming that its light bulbs last over 400 hours. And Kelso-Pre, we have to go through and show that's true. So, we need to take our histogram and convert it into a group frequency table. And then from that, work out the mean. So let's have a look at this. First things first, we're told the area of our first frequency of our first group is 5, and we simply get that by doing our 50 times by our 0.1 to give that area there is equal to 5. Okay. So for our next area, we know that it's 0.2 high, and it's also 50 wide. So it must have an area of 10. So we can stick that into our table. Okay. Next up, we've got our next group, which is 100 wide and 0.17 high. It's got 100 times 0.17. So that gives us 17. And then we're not told upper and lower bound for our next group. Fairly easy to work out from here. We've got this going between 200 and 500. So we're going to have 200 is less than or equal to t is less than 500. And then I've got 300 wide by 0.11 wide. So that's going to give us a frequency of 33. Okay, and then for our final group, we've got between 500 and 1000. John, not 100. So we've got a width of 500 and a height of 0.07. So that's going to give me a frequency of 35. Okay. So now we've done that, next up we need to get our midpoints. So let's call our midpoints x. So halfway between 0 and 50 is 25. Halfway between 50 and 100 is 75. Halfway between 100 and 200 is 150. Between 200 and 500 is going to be 350. In case you're wondering what I'm doing, simply I'm taking the lower bound and the upper bound, adding them together and dividing by 2 to find the mean, which will also be the midpoint. So then finally, between 500 and 1000, I've got 750. So hopefully now you know what we need to do is take our frequency and multiply it by our midpoint. So 5 times 25 gives us 125. 10 times 75 gives me 750. 17 times 150 gives me 2,550. 33 times 350 gives me 11,550. And 35 times 750 gives me 26,250. And no, I wasn't doing those in my head. I pre-calculated them. So next up, I need to work out two things. I need to work out the total frequency. Well, we're told there's 100 light bulbs. And then I need to work out the total length that they ran for. So I do that by simply adding all my fx's together. So if I add those together, I end up with 41,225. So my mean, which I will call t bar, is going to be my 41,225 divided by 100, which is 412.25 hours. Okay, now we have to be careful here and actually answer the question. We're being asked to show that this sample meets the company's claim. Very easy to lose a mark here. And we can do it simply by stating that 412.25 is greater than 400. Therefore, claim is true. Smiley face. Just because. Okay. So. Next up, question 4. Completing the square. I appreciate you guys probably didn't spend an awful lot of time on this at GCSE. It is, however, bread and butter for use of maths, and for A-level maths for that matter. So I'll quickly go through it here, and we'll cover it in lessons, and there's loads of YouTube videos on how to do it anyway. So, very quickly, if I've got 8x squared, take away 8x plus 12, when I complete the square, I'm going to do x. Now I'm going to have to halve my coefficient of x, so minus 4 squared. If I expand that, I'm going to end up with x squared minus 8x, which is what I want, but I'm going to have a plus 16, which I don't want. So I'm going to subtract by 16. So that expanded is equal to, it's going to work, it is, linear. So that and that are the same thing. So all I have to do now is add on my 12, and then, I'm running out of colours, aren't I? Ooh, don't do that. Thank you. All of that is now the same as all of that. So all I have to do is tidy up my expression here. My x minus 4 squared minus 4. Okay, so that's part A done and dusted. Part B. Again, I'll go through maths behind this in greater detail when we come to it in class, but hopefully you'll remember from GCSE that if I have a quadratic, then the turning point of the vertex has coordinates of, if my equation is written in the form y equals x minus a squared plus b, and that is going to be a b. So therefore, the minimum value has to be minus 4. So minimum value is equal to negative 4. Okay. So, right, that's all of the calculator questions done. Now we're on to the non-calculator stuff. So, the cube of 5, hopefully, you'll know that 5 cubed is 125. I believe that's one of the prerequisite bits of knowledge put down by the exam boards for a grade C at GCSE. The square root of 169, again, it's 13. You're expected to know what 13 squared is, ergo, you know what the square root of 169 is. Okay, bit of laws of indices. If I'm multiplying two numbers with the same base, then in this case a base of 5, then all I do is add the indices together. So that gives me 5 to the power 10. If I'm dividing two terms with the same base at different indexes, then all I do is subtract the index of the denominator from the index of the numerator to get r to the power of 9. Okay, part D. Anything to the power of 0 is equal to 1. So 16 to the power of 0 is equal to 1. Okay, fractional indices. The denominator is a root. So in this case, I need to do the cube root. And the numerator is the power, so I need to square. It doesn't matter which order I do it in. I can square first and then cube root, or cube root and then square. It's usually easier to do the rooting first, especially since the cube root of 27 is just 3. So it gives me 3 squared. Hopefully, it's going to be no great surprise. It's going to be 9. Okay. Notably, it's an odd root I took, so I didn't have to have the plus or minus in. We have to start with even roots. Okay. Oh, solving inequalities, an absolute gift of a question from GCSE, because it's exactly the same as solving an equation. For some reason, it takes a question which, if that's an equal sign there, would be around about a grade E. All of a sudden becomes grade C because it's an inequality. Go figure. So we're going to treat it as if it's an equation. So I want to get all my x's on one side, get rid of all the constants and coefficients on the other side. Since the only x's are on the left-hand side, let's get rid of all the numbers that we know rather, and stick them on the right-hand side. So let's get rid of this minus 2 by adding 2 to both sides. So 3x is less than or equal to 12. So then if 3x is less than or equal to 12, 1 lot of x I get by dividing by 3. That gives me 4. Just to the side, had that been minus 3 there? It's not, but if it was minus 3, hopefully you guys will have learned that when we divide through or multiply through by a negative number, we need to change the direction of our inequality. But it's not, so because x is less than or equal to 4. Okay. Right, question 7. The sketches of 3 different straight line graphs A, B, and C are shown below. Which equation matches to which of the graphs? So if you look at graph A, we've got a positive gradient, and it's going up as we go left to right. So delta y, delta x. But we're changing y. We're changing x. That's going to be positive in this case. So I'm going to left to right for delta x and going up for delta y. So it's going to be positive. So the gradient is positive. So straight away, that means I can rule out this one, and I can rule out this one. So we've got negative gradients. The gradient's -3, and then you can see that we have a negative y-intercept, so that rules that out because it will y-intercept to 5, and it rules that out because it will y-intercept to 5, which leaves me with A is y equals x minus 5. Okay, I can use a similar method to work out the equations for the others. So for B, I've got a negative gradient because it's sloping down from left to right. And so that means I can safely ignore the first, middle. In fact, I can ignore the middle for all of them because it's a quadratic. It's going to give me a curve. And the fourth one, so it also has a positive gradient. And because I've used it. So that leaves me with minus 3x plus 5 and minus 3x minus 5. Now that's our y-intercept there. It's a positive number. It's above the x-axis. Therefore, it can't be that. So it gives us that B is y equals minus 3x plus 5. Okay, so let's leave the ones crossed out that we've already used, and which it can't be. So it can't be the middle one because that's quadratic. It can't be x minus 5 because we've used that. then it can't be minus 3x minus 5 again because we've used that. So C. Okay, so we've got a positive gradient. If we look at what we've got left, it can only be that. And we can check that we've got a positive y-intercept. That's positive. And it's not sloping up as much as the other two. It's got a gradient of 1/2. However, we just be careful because it says sketches. So we can't guarantee that a shallow gradient on a sketch actually means that the gradient is shallow. However, in this particular instance, it does mean that. So C is going to be y equals 1/2x plus 5. Happy days. Okay, so moving on. Question. Solved by factorizing. Nice bit of factorizing a quadratic. I know you all love this. So let's have a look. So first things first, I've got a quadratic with 3 terms in it. So that means straight away it's going to go into 2 brackets. It factorizes. So GCSE questions tell me to do it by factorizing, so it's safe to assume that it does factorize. So 2 numbers that multiply together to give me 2x squared. That's going to be 2x and x. And then I need 2 numbers that multiply together to make it minus 6. So what could that be? I could have, I suppose, plus 3 and minus 2. But if I expand that, I'm going to end up with 2x squared, happy days, plus 6 minus 2. So that would be plus 6x minus 2x plus 4x. Well, that doesn't work, does it? So we're going to have to try something else, aren't we? 2x squared. What else could it possibly be? Let's try minus, let's say minus 2 and plus 3. Let's see if we've got it right this time. So we've got 2x times x gives us our 2x squared. That's already done. 2x times minus 2 is minus 4x. Ooh, well, it's negative. That's a good start. 3 times x. Hello. Looks like we're there. So minus 4x plus 3x is minus x. And plus 3 times minus 2 minus 6. Superb. We're there. 2x squared minus x minus 6. So that means we have 2x plus 3 times by x minus 2 is equal to 0. So what does that mean? It means that either that has to equal 0. So that means x is going to be minus 3 over 2. Or alternatively, it means that's equal to 0. One of those 2 terms must be equal to 0 because we're multiplying 2 numbers together. Then if I want them to equal 0, at least one of them has to be 0. So then x minus 2 equals 0. So x must be 2 in that instance. So my final answer to that question would be that x is equal to 2 or minus 3 over 2. Or you could say minus 1.5 or minus 1.5 if you so desired. Again, you'll notice we've solved a quadratic just like we did. Well, where was it? Where was the other quadratic we solved? Where was it? There we are. 2 part 3. There we solved a quadratic and had, where is it? 2 solutions, plus or minus 5. Here we solved a quadratic. And again, we've got 2 solutions, 2 or minus 3 over 2. Okay, moving on. Question 9. Solve these simultaneous equations algebraically. So, we've got various ways of doing it. Probably the easiest way of doing it is by elimination. So if I call this equation 1, call this equation 2, I need to somehow add or subtract some multiples of equations 1 and 2 so that I'm left with only one unknown. So what have we got? If I were to multiply equation 1 by 2, that would give me 2 lots of y. So I've got 2 lots of equation 1. That gives me 2y plus 4x equals 20. So now you'll notice that, let's call that equation 1b. So let's say 1b equals 2 lots of equation 1. You notice that 1b has 2 lots of y, and equation 2 has minus 2 lots of y. So if I add equation 1b to equation 2, those two y's are going to cancel each other out. So I'm going to have 2y plus minus 2y is nothing. 6x, 4x is 10x. And then 12 plus 20 is 32. So therefore x must be 3.2. Okay, not finished. I know what x is. Next up I need to work out what y is. So I can do that by substituting x equals 3.2 into either of those equations, and I'm going to substitute it into equation 1. It'll work just as well substituting into equation 2. So it gives me y equals, wrong, it doesn't give me y plus 6.4 equals 10. So then y must be 3.6. Hey! Happy days. So let's make life easy for the examiner. X equals 3.2, y equals 3.6. I say examiner, make life easy for myself or the other use maths teacher. Okay, so moving on to, I think, our final question. So, another pair of simultaneous equations, this time a non-linear one. We've got a straight line, 25 minus 7x, and a circle, x squared plus y squared equals 25. So let's have a quick look at what that would look like. Let's our axes. Let's draw ourselves a circle. Okay, so that's 25 there. No, it's not. It's 5 there. Minus 5. 5. Minus 5. Oh, crikey. Got the scale very wrong here, haven't I? So let's make that a lot smaller. A lot smaller. And then I've got 25 minus 7x. So there's another straight line coming from way up here and cutting down like that. So I need to work out the coordinates of those two red points there. So when I had two linear simultaneous equations, I did it by elimination. When I've got a non-linear simultaneous equation, my go-to method is usually substitution. So I know that y is 25 minus 7x, so that means that I can replace this y with my 25 minus 7x. It gives me x squared plus 25 minus 7x equals 25. So expand my bracket, squared, x squared plus 25 squared is 625. 25 times minus 7 times by 2 gives me 350. So minus 350x. And then 7 squared is 49. So plus 49x squared equals 25. So Want that, do I? Want that. Slightly equal signs, make things a little bit neater. Yes, I want you. Thank you. Line them up, I said, John. Thank you. Yeah. Okay. Sorry about that. So what have I got then? Oh, I've got x squared, 49x squared. That's 50x squared. I've got my minus 350x. Then I've got my 625x on the left. Wrong. My 625 on the left-hand side. I've got 25 on my right-hand side. Now it's a quadratic I need to solve here. In order to solve a quadratic, it has to equal 0. We need to find its roots. So I have to take my 25 away from both sides. So it leaves me with plus 600 equals 0. And at this stage, I'm guessing some people went kind of flibble because those numbers are really quite big. However, 50 is a factor of 50, 350 and 600. So I can take a factor of 50 out. It's going to give me x squared minus 7x plus 35. Plus 35? Idiots. Plus 12 equals 0. So then, so divide through by 50. My left-hand side becomes x squared minus 7x plus 12. And 0 divided by 50 is still 0. So I just need to solve that. It's a GCSE question, so I'm pretty confident that at the end of something like this, I'm not going to be expected to complete the square or use a formula. Almost certainly I'll be able to solve it by factorization. So, off to my mic there. So x and x, it's a quadratic with 3 terms, so it's going to go to 3 brackets, 2 brackets even. And then I just need 2 numbers that multiply together to give me 12 and add together to give me minus 7. So it's going to be minus 3 and minus 4. So once again, that means either x minus 3 got to be equal to 0, x equals 3, or that x minus 4 is equal to 0, in which case x is equal to 4. And once again, I'm not quite finished yet. We've worked out what x is, but now I need to work out what y would be. So if x equals 3, I can substitute that back into my 25 minus 7x. So means y is going to be 25 take away 7 times 3. So it leaves me with 4. And then if x equals 4, that gives me y equals 25 take away 7 times 4, which gives me minus 3. So again, to write out our solutions to make whoever's marking this life easy, we would say that x equals 3 and y equals 4, or x equals 4 and y equals minus 3. So have a quick look at our diagram to make sure that makes sense. So that's saying that that point there is 3, 4, and that point there is 4 minus 3, which, looking at it, makes sense. Okay, let's just double check. I'm pretty sure that was the last question. It was. Okay, so that's a bit of a whistle-stop tour of that test. Hopefully you got full marks, or got good results out of that. If you've got any problems or if there's anything you still don't understand, feel free to come and grab me outside of class and I will go through those questions with you. Or any other maths teachers are all more than capable of doing it. Okay, thank you very much, and I'll be talking to you soon. Cheers. Bye.